Hi, welcome back to educator.com. This lesson covers the history of XML. XML got its start as a result of the popularity of HTML, but even HTML has roots in earlier technology. In this lesson, we'll be taking a look at HTML's predecessor, known as SGML. We'll see how SGML contributed to the development of the World Wide Web, and we'll see how the success of the web led to the rise of XML. XML is engineered as a web-friendly simplification of SGML, which was in turn created to allow for the separation of an electronic document's data from its particular digital formatting. We need to start in the late 1960s. SGML stands for Standard Generalized Markup Language, and we'll take a look at where that rather convoluted name came from. A gentleman by the name of Charles Goldfarb, a trained lawyer and budding computer scientist for IBM, found himself assigned with an interesting task. He had to work with an organization that had a large collection of important documents, and they needed to work with those documents in three completely non-interoperable applications. They had a database of the documents where they could find the documents and retrieve them for whatever they needed them for. They had a text editor program where they could change the contents of the documents. And then they had a formatting printer which would take the contents of the documents and lay them out nicely on a page and print them out on paper. These programs had absolutely nothing to do with each other, and each of them needed their own custom procedural markup in order to deal with the contents of the file directly. For instance, let's say the text editor wanted to call something a heading, whereas the formatting printer wanted to call it format 17, which was defined somewhere as being typical of a document heading. And there was no easy way to switch the contents from one to the other without basically storing information in three different places, which really didn't make a lot of sense. So they needed some kind of solution as to how to store this information in a way that it was easy to retrieve for all three different applications. An idea that was popular at the time was called generic coding, the idea of removing application-specific coding for particular content and trying to find a way to make it universal and generic. So in that way, you could separate the content of a file from a way it was supposed to look for a particular application or even for a user. So Goldfarb, his colleagues Ed Mosher and Ray Laurie created what they called GML, and it's no coincidence that it was called GML in honor of their initials. Goldfarb later invented the term markup language to justify the acronym, and it became the solution to their problem. If they stored information in a central file using GML to mark up the contents as to which part of each document represented what, then as far as each of their machines were concerned that they had to format for, or each particular application, it could be sent to all three machines, and each machine would have its own interpreter that would be able to convert the generic form into a form that was customized for that particular application or machine. That way they could store all the information in one format in one place and then simply customize the information for however a particular application needed to use it. This became a very powerful idea, and Goldfarb continued to work with IBM on creating an international standard out of GML, which is where the S in SGML comes from. And this work was completed by the 1980s. And there were a lot of space-saving features built into SGML because computers of the 60s, 70s, and 80s were much, much slower and resource poor in terms of storage space than computers today. And SGML was originally designed for organizations that might have thousands, tens of thousands, perhaps even millions of important documents. So if you're going to mark up all these documents, meaning you're adding to the character count of each file, it's a good idea to come up with a way to save space where you can. So for example, if you had an SGML file which would normally be shown as an element with some content like this, SGML allowed you to change the definition of its particular language. So, for example, maybe you didn't need to include the ending tag of a particular element. You can also omit the starting tag if the context makes it clear what sort of element it's supposed to be. They also came up with what's called a shortening tag, where you start the tag and then put the content in between some slashes, and then that's it. So you can see this changes the character count and allows for a lot of space saving if you're talking about thousands of very large documents. You see quite a savings that way. Part of the problem with this, though, is that with so many different options, it becomes very difficult to program a system to handle all those different options, to look at a particular collection of text and understand what's going on in terms of which format of the elements are being used. So you end up getting very large programs that are designed just to try to deal with all the different options available. At this point, another figure enters the story. Tim Berners-Lee, in the mid-1980s, was an IT administrator at CERN, which is the European Particle Accelerator Laboratory. And at CERN, you have scientists coming from institutions all over the globe to run their experiments on the various devices there. While they're there, for perhaps a lengthy period of time, they might have their own office space. They'll be generating their own files and documents. They'll be storing them locally. And then eventually they go back to their own institutions, but they still might like to have access to the stuff they did at CERN, which also still might be of use to other researchers. So it's nice to have it available to everybody. But you have people bringing their own computers, bringing their own word processors, text editors. So everything is a big mash of different file formats. And it makes it, again, very difficult to manage this. And that was Tim Berners-Lee's job, was to try to figure out a way to manage this. So gradually he hit upon a solution. The internet was introduced at CERN because, again, you have people from all over trying to access information remotely, so the internet makes a lot of sense. He was fascinated by this idea of generic markup that was developed with SGML, which had recently been finalized as an international standard. Plus, in the mid-1980s, this amazing new technology was catching fire called hypertext, where you click on some text and it causes the computer to execute some other function, such as opening a completely different file or showing you a picture or a film or something. This was not a brand new idea in the 1980s, but it was certainly catching a lot of attention right around this time. So he took these three existing technologies, the internet, generic markup, and hypertext, and using those, he created the World Wide Web. The World Wide Web incorporates three technologies that Tim Berners-Lee developed. Firstly, since all the files he was dealing with were on different file systems, different computers have different way of indicating where a file is, using slashes, different symbols, colons, all sorts of things. So he created a uniform, that's what the U is for, means of locating resources. So URL, Uniform Resource Locator. Later he called it a URI, Uniform Resource Indicator, as we covered in another lesson. And these days they even call it an IRI to account for languages other than English. They call that an Internationalized Resource Indicator. And this is all for just locating the files and resources within a computer system that you need. You have HTTP, the Hypertext Transfer Protocol, which is how you send a message to a server to request a particular file, and the format in which that request is made, and also the format in which the file and its associated content are sent back to you. And he also needed to create a way to mark up the documents. So he created HTML based on SGML. This is the way that you mark up the documents if you're familiar with HTML, and now, as you see with XML, it's all very similar with these tags, delineated by corner brackets. You have attributes. This is all directly from SGML. So the HTML specification includes both the markup language and a description for how programs are supposed to handle it. So the web caught on in the still relatively small internet community like wildfire. This led to the period known as the browser wars. The very first web browser was called World Wide Web, and it was written by Tim Berners-Lee to operate on the Next Step system developed by Next Computing, which was Steve Jobs' company after he first left Apple before he came back. Some folks at the National Supercomputing Agency in Illinois created a browser called Mosaic, and from Mosaic sprang two of the most popular browsers of the 1990s, Netscape Navigator and Microsoft Internet Explorer. Now, what happened around this time was that each of the browsers was trying to attract market share. They wanted you to use their browser. In the beginning, the Netscape company actually charged for Navigator. It was actually supposed to be a profit-making piece of software. They were undermined by Microsoft, who could afford to introduce Internet Explorer for free to try to grab market share. And one of the ways the two browsers tried to grab market share was to invent their own custom elements that only worked in that browser. So that way, if they could convince web authors to use those elements, then it would only work in that browser, and that would make people want to use that browser more, supposedly. So for example, Netscape invented the image element. If you're familiar with HTML, that's how we show pictures in a web document. That was invented by Netscape. If you wanted to invent pieces of other programs written in C++ or Java or other languages that came later, Netscape invented the embed element that only worked in Navigator. Meanwhile, Microsoft Internet Explorer invented its own ways of doing things, tags that only worked in that browser. And it created a lot of confusion, and it created a web that wasn't interoperable. Tim Berners-Lee didn't like this, so he created the World Wide Web Consortium, known as the W3C. The W3C is made up of member organizations, and the member organizations are important computer science companies from around the globe. Browser manufacturers, content specialists, internet engineering companies, network companies. They all come together and meet and have members of their organization work on standards together to make sure that the web remains interoperable. So the Web Consortium in 1995 published HTML 2.0. Prior to that, there was no standard that specifically defined what HTML was and what it wasn't. So HTML 2.0, the first actual published web standard, ironically enough, was the work of the consortium to try to bring this all under one umbrella. Within a couple of years, they realized that there was still a lot of specialization going on and a lot of requests for different types of capabilities for web pages. They tried to come up with this by subsuming everything under the object element. Originally, the object element within HTML was supposed to encompass pictures, bits of programming, sound, media. But by the time they came up with it and finalized what it was supposed to look like, the image and embed tags had caught on so much that it became a problem. So the consortium decided to incorporate some of these specializations into the standard so that everybody could use them and programs could be done according to the standard, and that way everything would again be interoperable. And this was the impetus for the creation of HTML 3.2 in 1997. HTML 3.2 was the first web authoring language that a lot of people learned. It's also quite notorious these days because it was considered to be a hopeless hodgepodge of different tags from different manufacturers. You had a bunch of different elements that did the same thing. You had what the SGML purists thought was blasphemy, which you had presentational tags like B for bold and I for italic, and these would specify visual formatting, which SGML was supposed to be moving away from. So there was a lot of happiness about the publishing of HTML 3.2 and also a lot of anger. So there was clearly a desire for rapidly expanding web capability, but the World Wide Web Consortium operated rather slowly compared to some of the organizations that were eager to move the web forward. And SGML itself was too difficult to program for for enough people to be interested enough to immerse themselves in that standard in order to create kind of their own versions of web-appropriate languages. So into this void came XML. One of the primary authors of XML is a gentleman by the name of Tim Bray, whose photo you see there. And the idea of XML was to create a restricted syntax of SGML to make it easier to program for, and that way it would make it a lot easier for people to create their own web languages. That way the Web Consortium didn't have to worry about constantly expanding HTML. They could simply focus on developing other web technologies, and anybody who really wanted something in a web language that HTML didn't do, they could use XML to author it themselves and describe it themselves so that people could program for it. So some differences between XML and SGML. All tags are required in XML. You have to have a start tag, you have to have an end tag for every element. All attributes have to have values, and all attribute values have to be in quotes. Early versions of HTML included attributes where you just had to include a name, and that would enable some capability. In XML, you're not allowed to do that. You have to have an attribute, an equal sign, and a value in quotes. Again, it seems a little awkward. Sometimes it's hard to remember to do if you're coding by hand, but it makes it a lot easier to program for and makes adoption of a new web technology a lot more likely. They also came up with the empty tag syntax. So for instance, you could have an E tag along with some attributes and values. And then you'd end it this way with a slash before the end of the start tag. This was meant to be interoperable with SGML processors. XML was conceived as simply a version of SGML. It wasn't supposed to be a separate new thing. But a lot of SGML enthusiasts and purists, even though SGML isn't widely used in the field anymore, got really upset that this slash format was using. They're saying that's not going to work with a pure SGML processor. It's going to trip it up. It should create errors if it's a standards-based SGML interpreter. And a lot of people say that XML really isn't an SGML dialect. It's a completely separate thing, even though it looks almost identical. So if you look around on the internet enough, you can find raging arguments about this in forums, chat rooms, that sort of thing, as to whether XML actually is an SGML dialect or whether it's its own separate language. So XML was first published in 1998, and the plan originally was for all web development to move over to XML in one form or another. The first step was to get HTML translated as an XML language. So the final version, or what was then the final version of HTML, version 4.01, was published in 1999. And the first version of XHTML, the Extended Hypertext Markup Language, which was HTML 4.01 based in XML, was released in 2000. As I mentioned earlier in the course, the Web Consortium at that time wasn't particularly careful about broadcasting this information in a really clear manner. So a lot of people remained confused for a long time about what happened to HTML and whether or not XHTML was really a web authoring language or not. These days, the Web Consortium is now focusing on HTML5, which kind of removes the XML restrictions. And it's hard to say exactly what the future of HTML is as a result. But there are a lot of XHTML applications. XHTML is the one you're supposed to use if you're going to use namespaces to incorporate things like SVG or use an XSL style sheet, that sort of thing. But some browsers will kind of overlook that and let you work with it anyway. So the intention of XML originally was to provide for a way to make the web easier to program for in order to expand it under the auspices of a standard without waiting for the standard setting body to do all the work. So in this lesson, we've seen how SGML led to the rise of HTML, which eventually led to XML. We see why it is that XML and HTML are not equivalent. HTML in its original versions is based on the freer syntax of SGML, whereas XML is more restricted, so they're not completely compatible with one another in their native form. So as a result, XML gave rise to an XML-based version of HTML, XHTML, and we've taken a look at some of the controversy as to whether XML and SGML are actually equivalent. So it's a convoluted history, but there you have it. Thank you for visiting educator.com.